Okay, 8th grade, this is the last one that I'm going to say is really the prerequisites or the real fundamentals or basics of linear functions and graphing that we really need to know and to have memorized or a good understanding of is what we really need. So calculating slope. Slope is just comes up over and over again. So we need to know it, we need to know it well. So let's talk about a number of different ways to understand slope. Slope is represented by the variable m. That's very important. And we can define it in a number of different ways, and we're going to see what they look like during this video. But the first way to talk about it is it's just the amount y changes whenever x increases by 1. So especially if you think about the graph, as x increases by 1, we move to the right. I'm doing this backwards to, I think is that your right? Yeah. So as x increases or goes to the right 1, how does y change? Does it go up? That would be positive. Does it go down? That would be negative. Does it go up a little bit? That would be a tiny slope. Does it go down a whole lot? That would be a really, really negative slope. So it's the amount y changes whenever x is increased by 1. 2, it is considered the change in y over the change in x, or the change in y divided by the change in x. 3, a really basic way to describe it is to say, what's the slope? Oh, that just tells us how steep the line is. So again, as we go to the right, as we increase x by 1, how steep is it? Does it go up to the right really steep? That'd be a big slope, big positive slope. 4 kind of goes with number 2. Should have put them next to each other so you can like draw an arrow to each other. But if we're talking about the change in x over the change in y, that'd be y2, or a second y coordinate, minus y1. That tells you the change. So if I say, what was the change in Mr. Schwartz's weight this year, you would have to find my weight at the end of the year and subtract it from the beginning of the year. That would be finding the change. So the change in y divided by the change in x means y2 minus y1 over x2 minus x1. And the last way to understand it is we commonly see linear functions written as y equals. And if you do, then the slope is just the number that comes before the x. It's the coefficient of x. So that's a little trick because I know we're going to see it a lot. What are the other notes we have? It can be graphed it can be calculated quickly by looking at a graph, and 2, it can be calculated also by plugging in 2 points into the equation. So if you don't have the graph, but you have 2 points, let's say you have, we're going to see this in a minute, but I'll give you an example. 5, 3, and negative 10, negative 27. Well, then you can say, okay, what if this is x1 and this is y1, because they are the first ordered pair I'm going to name. Then this would be x2, I'm naming it second, and it's the x value because it comes first in that ordered pair, and this is y2. So we could just plug in these numbers, 3 for y2, negative 27 for y1, 5 for x2, negative 10 for x1. And we could just plug them in right into that equation and we could calculate it. But I'm going to show you how to also just look at the graph to understand it. So let's do that. Let's look at the first example. And this doesn't have a scale written, but we're going to assume that it's 1. If the scale is not written, we just assume that it's 1. Now we need to find 2 points to talk about this, and we can't just choose any points because I can't tell how far that point is down. It looks like it's past negative 2, but not quite to negative 3, so we can't choose that. We want to choose right where points are at the intersection of our scale. So let's use this. This is a good one to use. It looks like it's right on the intersection of negative 2, negative 2. And then let's also choose, where's another one? This is right at the intersection of 2 to the right, then down 4, negative 4. Now we know that it's the change in y, and we can represent this by using delta. Delta, or triangle, means the change. Change in y over the change in x. I'll write that just so we know. So please write this with me. Change is delta. Change in y over the change in x. So we could plug those points into the slope equation, or m equals y2 minus y1 over x2 minus x1. That'd be a lot to do. What I would like to do is say, okay, how much does y change? What does y change as we go to the right? Well, it goes down 2. So the change in y is negative 2. What's the change in x between these 2 points? Well, x, we move to the right 1, 2, 3, 4. We move to the right 4 points. What's a simpler way to write negative 2/4? Well, that's just negative 1/2. So the slope here is negative 1/2. And we found that right away. We could plug it into the equation. M equals y2 minus y1 over x2 minus x1. We could plug in those points we just named and call one of them the first ordered pair x1, y1, the second one x2, y2. But we can just look at the graph. The final thing I want to do is check this. Does this make sense to us? Well, we know that slope is also however much y changes when we increase x by 1. So what about right here? We went from negative 0, negative 3. As we go to the right once, it looks like, yeah, it did go down half of a unit. Y changed to negative 1/2. It went down half of a unit as we increased x, or moved to the right once. So that makes sense. What about this one? What if they give us the points? Well, if they give us the points and not the graph, we can't just see that quite right away. So let's do m equals, and I'm going to ask you to maybe start using that notation. Change in y over change in x, which is y2 minus y1 over x2 minus x1. Now I'll tell you that the most common mistake I have students making here is they're mixing up their y's and their x's and their 2's and their 1's. So what I want you to do whenever you write this, I want you to name your first ordered pair x1, y1, and I want you to name another one x2, y2. And that way you can check yourself. You can plug in the exact right numbers. So y2 we'll say is 10, subtraction sign. y1 minus y1 is 5. x2 we check is negative 6. x1 is 4. Now we can calculate this really quickly. 10 minus 5 is 5. Negative 6 minus or add up plus negative 4, that's a total of negative 10. This is another slope that can simplify to negative 1/2. So there we use the slope equation, the slope formula. M equals change in y over change in x, y2 minus y1 over x2 minus x1. Did I give you another one to do? I did. I always buy a pack of Big League Chew at the collector's store for $2, and I buy or sell packs of baseball cards for $5 each there too. $5 each because I repeatedly buy those. In the linear function that tells how much I pay during a visit, what is the slope? So the function is going to tell us how much I pay. We'll use f of x this time. So it's a function that tells how much I pay, and it's based off an independent variable. What is that independent variable? What's the thing that I'm going to change each time? What's the number of packs of baseball cards I buy? And every time I buy another pack of baseball cards, I buy or sell packs of baseball cards for $5 each. So 5 times the number of packs would give me the price I'm paying. And then I also have to add that $2 for Big League Chew. So what's the slope? Well, every time I increase x by 1, every time I increase the independent variable, again, the independent variable is how many packs I buy. What is y doing? Every time I buy one more pack, my total cost is doing what? It's increasing by 5. So in this case, my m is positive 5. And hopefully you remember I said when y equals or f of x equals the coefficient of x, the number in front of x is the slope. But hopefully it also makes sense that that's how much y, or my output, increases every time I increase my x by 1. So hopefully that one makes sense too, that the slope is the number that goes with our independent variable in word problems. It's the number that we're repeatedly multiplying. It's the number that I'm having to pay over and over again if I buy more cards, more packs of cards. I'm not going to give you a word problem just yet. Instead, I'm going to give you these two to do on your own. The first says, find the slope of the line through negative 4, and I hope you're listening because I'm going to change this. Negative 4, negative 10, and 367. That'll work out a little nicer for you, I think. And the second one says, find the slope of the following line. It's going to help you out a little bit. The good, really, intersection points I see in this one are right here. 3 to the left is on the x-axis, just 3 to the left of the origin. And another good point might be this one up here. Yeah, let's use that. 1, 2, 3, 4, 5. 6 to the right. 1, 2, 3, 4, 5. 6 up. 6 to the right, 6 up. And again, 0, negative 2, or negative 3 to the left on the x-axis. So use one of those, calculate some slopes, and I'll catch you later.